You know what? Nobody tells you about the speed of light. It's not just fast. Fast as a Ferrari. Fast as a bullet. Fast as even a rocket. The speed of light is something fundamentally different. It's a wall, a cosmic speed limit baked into the fabric of reality itself. And nobody put it there. There's no sign, no law passed by anyone. It just is. And here's the thing that really gets me. If you actually traveled at the speed of light, you wouldn't experience it as fast at all. You wouldn't feel anything. Because for you, time would stop, not slow down. Stop, you'd be frozen in an eternal moment, spread across the entire universe simultaneously, while billions of years pass for everyone else. That's not science fiction. That's what the equations say. That's what the experiments confirm. And today we're going to understand why. My name is Richard Feynman, and I want to teach you physics, not by giving you formulas to memorize, but by making you feel why the universe had to be this way. All right, 1887. Two scientists, Michelson and Morley, set up one of the most important experiments in history. They were trying to measure how fast Earth moves through the ether. The ether was this invisible stuff everyone assumed light traveled through, like waves traveled through water. Here's their logic. If light travels through ether and Earth is moving through ether, then light going with Earth should appear faster, and light going against Earth should appear slower. Simple, obvious, wrong. They measured and measured and measured again. Same speed. Every direction, always. That's the scandal. That's the thing that broke classical physics. Light doesn't care which way you're moving. You can run toward a flashlight or away from it. You'll always measure the same speed. 299,792,458 meters per second. Now, in everyday life, speeds add. If you're on a train going 100 km/h and you throw a ball at 50 km/h, someone standing still sees the ball moving at 150 km/h. That's just sense, but not with light. If you're on a spaceship going 99% the speed of light and you shine a flashlight forward, you'd still measure that light leaving you at exactly the speed of light. And someone standing still outside your ship, they'd also measure it at the speed of light, not 1.99 times the speed of light, just the speed of light. How is that possible? It's possible because, and this is the key, the universe is cheating. It's bending time and space so that the answer always comes out the same. That's Einstein's insight, special relativity, published 1905. He was 26 years old and working in a patent office. Nobody asked him to solve this. He just couldn't stop thinking about it. Let me tell you what time actually is. Because you've been lied to your whole life, not maliciously. Just by habit, we all grow up thinking time is this universal river, flowing at the same rate for everyone, everywhere. Tick, tick, tick. A cosmic clock in the sky that we all share. That's wrong. Time is local. Time is personal. Time is what your clock measures, and your clock depends on how you're moving. Here's the experiment. Take two identical atomic clocks. Set them to the same time. Put one on an airplane flying around the Earth. Leave the other one at the airport. When the plane lands, the clocks don't agree. The one that flew is slightly behind. It experienced less time. This isn't an error. It isn't drift. It's called time dilation, and it's been measured precisely. GPS satellites account for it every single day, or your navigation would be off by kilometers. Now dial that effect up to light speed. Imagine a spaceship, let's call it the Feynman Express, traveling at 99% the speed of light. Inside the ship, we put a clock, a very simple clock, a pulse of light bouncing between two mirrors. Tick light goes up, tock light comes back down. 1 second, now you're watching from outside. From your perspective, the ship is moving forward very fast, so the light pulse isn't just going up and down, it's tracing a diagonal path, a longer path, but the speed of light can't change. It's the same inside and outside. So if the path is longer and the speed is the same, the time between ticks must be longer. Their clock is running slow from your perspective, and from their perspective, everything is fine. Their second feels like a second, their coffee is warm, their heart beats normally, they don't feel slow. But if they look out the window at your clock, yours looks slow to them. This is not a contradiction. This is not a paradox. This is just reality. Time is not a river. It's more like a river that flows differently depending on where you're standing or how fast you're moving. At 99% light speed, time dilates by a factor of about 7. 1 year on the ship equals 7 years outside. At 99.9% light speed, a factor of 22. At 99.9% light speed, a factor of 22. At 99.999%, the speed of light. Over 700, you'd return from a year-long journey and find 700 years had passed on Earth. The dinosaurs went extinct 65 million years ago. With enough speed, you could theoretically visit that. Not instantly, but the subjective time for the traveler shrinks towards zero as you approach light speed. And at exactly light speed, the time dilation becomes infinite. Your clock stops. From your perspective, you leave and arrive at the same moment. The entire journey happens in zero time. You don't experience traveling. You don't experience anything. You simply are everywhere along your path simultaneously in one eternal instant. Now let's talk about the other problem with going fast. You get heavy. Not fat, heavy. As you accelerate toward the speed of light. Your mass increases the faster you go, the more mass you have, and the more energy it takes to accelerate you further. Think about pushing a shopping cart. Empty cart, easy to push. Full cart, harder. Now imagine the cart gets heavier the faster you push it, and heavier still, until pushing it harder barely moves it faster at all. That's what happens to matter approaching light speed. You need more and more energy for less and less extra speed. And at exactly light speed, the energy required becomes infinite. You can't get there. Not if you have mass, not even a little bit of mass. This is why the speed of light is the speed limit. Not because there's a cosmic traffic cop, but because the math says to cross that line requires infinite energy, which means you can't but photons, particles of light, they can travel at light speed. Why? Because they have zero rest mass. No mass at rest. They don't accelerate to light speed, they're born at light speed. They've never been anything else. And this brings us to the most famous equation in history, E equals mc squared. Einstein's wild little formula. Energy equals mass times the speed of light squared. What does it mean? It means mass and energy are the same thing, just different forms of the same stuff. And they're connected by this enormous number c squared, about 90 quadrillion meters squared per second squared. That's why a tiny bit of mass converts to an enormous amount of energy. A single gram of matter, fully converted, releases as much energy as the atomic bomb dropped on Hiroshima. Not because atoms are magic, but because the speed of light is enormous. And when you square it, you get this incredible lever that converts mass into energy at a terrifying ratio. This is also why nuclear reactions work, why the sun shines, why stars explode. When a star collapses, some of its mass converts directly to energy, outward energy that dwarfs anything we can produce on Earth. And it all traces back to c, the speed of light. This one number, baked into the structure of space-time, connecting everything. We've been talking about light like we know what it is. Let me complicate that. Light is an electromagnetic wave, oscillating electric and magnetic fields, propagating through space, carrying energy. James Clerk Maxwell figured this out in the 1860s and almost accidentally calculated the speed at which these waves should travel. It matched the measured speed of light. Exactly, he wrote in his notes. Essentially, this must be what light is. One of the most powerful predictions in the history of science, confirmed by a calculation, not an experiment, but light is also a particle, a photon. If you shine light onto a metal surface, it knocks electrons off, but only if the frequency is high enough. Not intensity, frequency. Brighter light with the wrong frequency does nothing. Dim light with the right frequency knocks electrons loose. That's the photoelectric effect. That's what won Einstein his Nobel Prize, not relativity, this. And it proved that light comes in discrete packets, quanta, photons. So which is it? Wave or particle? Yes, it's both. It behaves like a wave when it travels, like a particle when it interacts, and there's no deeper picture underneath, no hidden mechanism. At the quantum level, reality just works like that. You can ask, but what is it really? And the honest answer is, the question doesn't have a form that makes sense in nature. Feynman used to say, if you think you understand quantum mechanics, you don't understand quantum mechanics. I think he was right. But here's what we can say. Light is the thing that connects space and time. It's the messenger that carries all information across the universe. No light, no knowledge of anything beyond what you can touch. The stars you see tonight are pictures from the past. Some of them no longer exist. Their light left before civilization did. Andromeda Galaxy, our nearest neighbor, 2.5 million years away, in light travel time. When that light left, humans hadn't invented language yet. We are surrounded by history, coded in light, arriving constantly, telling us stories from the deep past of the cosmos. Okay, here's the last piece, the one that makes physicists stay up at night. If you could travel at the speed of light, if you were a photon, you would experience no time. Zero. You leave a star and arrive at an eyeball in what, from your frame of reference, is an instantaneous event. The photon from the sun, the one that hits your retina on a summer afternoon, that photon, in its own reference frame, left the sun and arrived at your eye at the same moment. The 8-minute journey we experience, the photon experiences none of it. For the photon, the entire universe is flat. Space is contracted to zero length along the direction of travel. There is no distance to cover, because the light speed contraction compresses it all. The photon touches every moment of its journey simultaneously, birth and death at once. The emission and absorption are a single event. Somehow, light, which carries all information across the universe, which enables sight and warmth and life, experiences none of the journey itself. It's a messenger that never travels, a thing that connects without ever being in between. I don't have a tidy bow to put on that. I don't think there is one. The universe is strange. Not strange in a way that breaks. Strange in a way that is. And the closer you look at light, at this one constant, this one number, 299,792,458 meters per second, the more it seems like the universe is organized around it, built from it, not because we put it there, but because it was always there and we're only just learning to read it.